Alright, this is part 4 of the college algebra final review key. So we're starting off with problem number 31 and we'll finish up with problem number 40. This says find the inverse of the function f of x equals the cube root of x plus 5, and then is that a plus or a minus? Can't tell. Minus 7. Okay, so the process for finding the inverse function was, the first thing we would do is we replace the fx with y. And then we're talking about the inverse, so the inverse is going to have us switch the x and the y, so we switch the x and the y. And after we've done that, we're going to solve for y. So we're going to plus 7 to both sides. So we have x plus 7 is equal to the cube root of y plus 5. And then to undo that cube root, we're going to do the third power of both sides. So we have x plus 7 quantity cubed equals y plus 5. We'll go ahead and subtract 5 from both sides and replace y with f inverse of x, okay? So the last steps we did is we solve for y and then replace y with f inverse of x. Notice that I didn't cube that out or expand it. You can if you want to. I would suggest not, but you can. Alright, let's do another one. Oh, looks like I wrote the steps in afterwards. Alright, anyways, let's move on to the next one. Find the inverse, and which one are we going to do this time, of f of x equals 2x plus 5. Okay, so replace the fx with y. And then we'll switch x and y. And then we'll solve for y. So we'll solve for y by subtracting 5 and then dividing by 2. So subtract 5 and then divide by 2. And then we'll replace the y with f inverse of x. Okay. So last step, replace fx. Replace y with f inverse of x, and that's your inverse function. Alright, let's see what else we got. So here we're given f of x is equal to 1 over x plus 5, and then g of x is equal to 1 over x. And part A, they would like us to find the composition f composed with g of 1. And so when we do that, that notation means we're going to plug 1 into g first. So plug 1 into g, 1 over 1 equals 1. And then we're going to take that 1 and we're going to plug it into f. And f is going to take that, put it in the denominator, add 5 to it, and then we get 1/6. Okay? Then the part B, we're going to find f composed with g of x, and maybe they'll ask us to find the domain also. So f of g of x, and so when we're finding the domain, we got to honor the inner function, which is 1 over x, and so we start out, we can't divide by 0, so x cannot be 0 here. And then we're going to plug that into the function for the input, so 1 over x plus 5. The common denominator is x, so we're going to multiply the top and the bottom by x, so we get x on top, and then 1 plus 5x on the bottom. We do have a new denominator, so we're going to set that not equal to 0. So x cannot be negative 1/5. And so our domain is going to be everything except for our two restrictions. So we couldn't be negative 1/5, and we also couldn't be 0. So that number line can help us with the interval notation. So negative infinity to negative 1/5, union negative 1/5 to 0, and then 0 to infinity, and then you have your composition formula right here. Okay. Alright, problem 34, f of x is equal to 3x minus 2, and g of x is equal to x squared plus 5. Part A says let's find f minus g of 2, so that means plug 2 into f, and then subtract from it g of 2. So 3 times 2 minus 2 minus, very important to have these parentheses here. This is where most of the errors are made, so it's minus the entirety of g evaluated at 2. So that means we need to work the parentheses out first before we subtract. And so that's going to give us 4 minus 9, so that won't give us negative 5. And part B says, okay, well, find f times g. So it's not the composition dot. It should be nice and solid. Okay. And so that means the formula for f times the formula for g. And so that's going to be 3x minus 2 times x squared plus 5. And we can just FOIL it and collect like terms if there are any, and then probably write it in descending order. And that's all we're going to do there. So nothing too crazy. So in descending order, 3x cubed minus 2x squared plus 15x and minus 10. Alright, what do we got now on the next one? So number 35, what do they want us to do here? Expand and write powers as factors. Okay, so we had a couple of these on our exam 4. So we have the ln of x cubed times the square root x plus 5 over 3z. Okay, and so the first thing we're going to do is we're going to take care of this multiplication dot, and then we're going to use the power rule. So we'll do that power rule first. And then we'll go ahead and do the power rule and bring the 3 down on that first log. And then on the second log you have a quotient, so we're going to use the quotient rule. And then we're going to also go ahead and rewrite square root is the same thing as the 1/2 power, so this is going to save us a little bit of time because we're going to want to drop down that 1/2 in front because they want us to write powers as factors. And then we have the ln of 3z, and so that was using the quotient rule. Now the first ln is good to go, and then we're mentioning here the square root is the same thing as 1/2 power. So nothing to do with that first ln there. We can use the quotient rule to bring down the 1/2, not the quotient rule, the power rule, excuse me. So that's using our power rule. And then we got to be a little bit careful, so it's negative because it's all came from the bottom, and then we have a product, and so it's going to be the ln of 3 plus the ln of z, and it all came from the bottom, so it's going to end up having the negative sign, and we're using the product rule. Okay, and so we'll distribute that negative sign, and we'll have 3 ln x plus 1/2 ln x plus 5, and then distributing that minus sign, minus ln 3 and minus ln of z. Okay, and there we'll mention that we went ahead and distributed. Okay, I think we got one or two more here. Okay, so here we're going to go ahead and draw this in. So this is the shape that they start you out with. So 2 line segments together. And they're going to ask us to do some transformations with it. Okay, so this is a non-parent function. They're going to ask us to do some transformations. So 36 is saying, okay, well, before we do that, we're going to find the domain. So the domain is the far left, far right, so that's going to be -2 to 1, and both the -2 and 1 are included, so we do have the brackets. The range is low to high, so the lowest it is on the x-axis, and that's 0, and the highest it gets is 5, and it actually achieves both of those values, so it's 0 to 5. Okay, now 37 we're actually going to do a transformation. So f of x minus 3 minus 2, Now if it's inside with the x, that's going to control left to right. It's going to do the opposite of what you expect. So that x minus 3 is going to slide everything to the right 3, and then outside is going to shift it down 2 units. So we're going to go right 3, and is it down 2? Oh, I don't remember if the problem was, let's go ahead and do up 2. Maybe I didn't write the problem down correctly. Anyways, so let's just roll with it's up 2, because that's what we're going to end up doing here. If it was minus 2, then instead of going up 2, I would go down 2. Okay. So I'm going to go ahead and do that. So the 3 points there, I'm going to move each one to the right 3 and then up 2. Okay. And then I'm going to redraw my shape there, so a nice rigid transformation, so nothing has changed. We just move it to the right 3 and then up 2. Now for 38, they want us to graph the inverse. And so what I would do is, because we have 3 good points. We got the -2, 0, the 1, -4, and then we also have the point 1, 5. So what I would do is I'd write those down, and then because we're doing the inverse, we'll go ahead and switch the x and y on each one of those, and then we'll plot them. So there's the 0, -2, and then we'll switch the -1, 4 to 4 and -1. So we'll go ahead and plot that. We'll get that out of the way, rewrite it. And then the last one is 1, 5 will get switched to 5, 1. So we'll go ahead and put that in also, connector line segments, and then there's the inverse function there. You could also, if you wanted to, draw in the identity, and the function and its inverse are going to be reflections over the identity y equals x. Alright, I think we're going to do a little bit more transformations. So 39, they would like us to graph x cubed. And so we constructed a table in class. Nice numbers to use are, some small numbers, and then we'll cube all of those. Okay, and we'll go ahead and plot those points, and then draw the kind of looks like a snake, our cubic function. So there is our cubic function. Alright, and then they want us to do a transformation. So x minus 4 to the third minus 6. So that's going to tell us to go right 4 and then down 6. So we're going to take each one of those points and we're going to move them to the right 4 and down 6. So this is going to be a nice rigid transformation. So that's what we're going to do for each one of those points. Right 4 and then down 6. Okay, right 4, down 6, right 4, and down 6. And so we're going to have the same shape shifted to the right 4 units and then down 6. Looks like I didn't write down 6, did I? Okay, there we go, down 6. Okay, and so there is our transformation. I think we got one more transformation going on the next slide. I think we're doing the absolute value, the v. Okay, so we'll go ahead and draw the parent function, the absolute value, and we pick numbers close to 0, so minus 2 to 2 will work. We'll plot those points, and it looks like a v. And then the g of x, they're going to have us use this to graph a transformation, which is negative absolute value of x minus 3 plus 5. So we'll kind of work our way inwards, outwards. So the minus 3 is going to slide us to the right 5 units. 5 units, sorry guys. 3 units, so right 3 units. And then you got that minus sign in the front there, and that's going to reflect it over the x-axis, so it's going to be flipped over v. And so we're going to reflect over the x-axis. So let's add that over x-axis. And then up 5. So what I think I did is I only did the right 3 and then the reflect. Okay, so there's the right 3 and the reflect. And then what I did is I took each one of those points, so this was the right 3 and then reflect, so there's your upside down V, and then I took each one of those and I moved them up 5 units. So I then do as many steps at the same time. And then we will go ahead and draw our V. And there is our new function there, the g of x.